Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 14, using algebra to model geometry. This is our last lesson in Unit 3, which is a pretty long unit. And what we're going to be doing all throughout today's lesson is we're going to be using facts that we've learned, geometric facts that we've learned, throughout this unit, but we're going to use algebra to kind of model and solve problems involving geometry, all right? So a really good connection between the algebra and the geometry. Now, we've been doing a little bit of this here and there, but today we thought we would concentrate on it exclusively in this lesson. So let's jump right into it, all right, where we look at the first problem that we model geometry using algebra. All right, here we go, exercise number 1. In the diagram shown, points A, B, and C lie on a straight line. Ray BD is drawn such that the measure of angle ABD is 88 degrees more than the measure of angle DBC. Letter A asks us, what is the geometric relationship between angle ABD and angle DBC? All right, so before you really model things with algebra, in my personal opinion, you should understand the geometry of what's going on first. So that's really the question in A. What is the relationship between angle ABD and angle DBC? Pause the video now and see if you can write something down. All right, well, I hope that you wrote one of two things down. Hopefully you either said the two angles are supplementary, or you said they add up to 180 degrees, which is the same thing as saying that they're supplementary. But it's good to kind of review both. So let's get that down, all right? All right, so first, come on, P, there we go. I cannot get my pen to write. Let's try that one more time. We're gonna say they are dead spot. They're supplementary, or they add to 180 degrees. There is just a spot on that board that doesn't want to write. All right, well, that's an interesting looking P. All right, so the two angles are supplementary, or another way, they add up to 180 degrees. Now, let's take a look at letter B. Model their relationship using algebra. Find the degree measure of both angles. All right, so let's talk about how we model their relationship using algebra. What do we know? We know that the measure of angle ABD is 88 degrees more than the measure of angle DBC. Now notice, right, that the measure of angle ABD is based on the measure of angle DBC, right? They tell us about something about ABD based on DBC. Whenever that happens, what I like to do when I model something algebraically is I like to let the angle that everything is based on be the letter X or the letter N or, whatever variable you like, right? Then the measure of ABD is 88 degrees more than this one. Now that's easy, right? That means that this must be X plus 88. It's pretty much that simple, right? If this angle's measure is 88 degrees more than this angle's measure, if this one is X plus 88. Now don't get me wrong, you could also let this one be X, but then this one would be X minus 88, and that would be fine. It would all work out the same. You'd get a different value for X, but it would at least model the problem properly. Now, so far we haven't really done much except for just model the relative values of these two angles. Now we want to use the fact that they add up to 180 degrees. So what are we going to do? Well, we're going to say if I take one of those angles and add it to the measure of the other angle, right, that has to be 180. And truly, this equation models all of the information that we know in the problem geometrically. It also is enough to now allow us to find the measure of both of the angles. Pause the video now, solve this equation, and then find the measure of both angles. All right, well, simple enough. Let's start by combining these two x's, right? X plus x is 2x, right? This now boils down to a nice two-step equation, right? We can solve that by subtracting 88 from both sides. And this is a place where it's kind of handy to have a calculator, but you could certainly also do it without a calculator. 180 minus 88 is 92, right? And now I just want to divide both sides by 2, right? And that's going to give me 92 divided by 2, which is 46 degrees. Now that's the measure of one of the two angles, and in fact, that's the measure of angle DBC, right? The other angle is going to be 46 plus 88, right? Which is going to be 134 degrees. And that's going to be the measure of angle ABD, 134 degrees. One of the nice checks on this, right? Notice that I figured out the measure of ABD by taking the measure of DBC and adding 88 to it because we knew that it was 88 degrees more. But now I could do just kind of a quick mental check and I could say, is 134 plus 46 equal to that 180 degree angle that I modeled this problem on? And the answer is yeah, right? 46 plus 134 is 180. So I'm pretty confident that I have the answer correct. And again, it's a classic situation where we've got some kind of geometric setup, two angles that when added together form a straight angle or a 180 degree angle. Then we know something about how the two angles relate to one another, so we can kind of phrase that algebraically, x and x plus 88, and then we can model the problem geometrically like this, and then use some basic algebra to find the measure of both angles. We're going to be doing that a lot in today's lesson, so let's take a look at the next exercise. All right, here we go, exercise number 2. Below, lines AB and CD intersect at point E. Consider the angle pair angle AED and angle BEC, whose measures are given by the measure of angle AED is 8x plus 18, and the measure of angle BEC is 12x minus 42. Letter A asks us, what type of angle pair are angle AED and BEC? All right, so in the last problem, we were dealing with an angle pair that was supplementary. The two angles were supplements, meaning that they added up to 180. This time, though, we're talking about angle AED and angle BEC. So, I'd like you to pause the video and actually answer both letter A and letter B. What type of angle pair are they, and what's the relationship between their measures? Pause the video now and see if you can answer both A and B. All right, well, if we're talking about this angle here, right, and this angle here, these two angles are vertical angles. I feel like I have to write an N somewhere else. They're vertical angles, right? And they are equal in measure, right? One of the important things that we learned during this unit is that two angles that are across from each other, right? Two angles that are formed when two lines or rays or segments cross each other, and those angles are across from each other, those two angles have equal measures, all right? Now we want to find the value of x. And this is actually pretty easy, right? Because we know that AED is 8x plus 18, and we know BEC is 12x minus 42, right? We want to solve for x. Why don't you go ahead, pause the video, and do so. All right, well, if the two angles are equal in measure, then it's pretty straightforward. I'm going to set 12x minus 42 equal to 8x plus 18. Let's do that. All right, give myself a little bit of room here. 12x minus 42 is equal to 8x plus 18. Nice equation with variables on both sides. I think I'm going to move the x's first. I'm going to subtract an 8x from both sides. All right, give myself a little bit more room. That's going to give me 4x minus 42 is equal to 18. Now I've got a classic two-step equation. I'm going to just add 42 to both sides, right? Maybe I'll take it up to here. 18 plus 42 is 60. Now I'm going to divide both sides by 4, and x is equal to 15. Again, very, very important that we understand, we've got these two vertical angles. What does that tell us? The angles are equal. Okay, what do I do with that? Well, since they gave me the measure of the two angles, I can set them equal and use that to solve for x. All right, so far what have we seen? Supplementary angles, two angles that add up to 180. Vertical angles, two angles that have the same measure. Let's see what we have next. Exercise number 3. A rectangle is a parallelogram that has all right angles. In the diagram below, rectangle MNPQ has diagonal QN drawn in it. It is known that the measure of angle QNP is 2 degrees more than 3 times the measure of angle MNQ. What is the relationship between angle QNP and MNQ? All right, so what I'd like you to do, pause the video, take a look at this situation, and answer letter A. What is their relationship? All right, well, it's very important when you're dealing with angles that have 3-letter naming system, which we've mostly been dealing with in today's lesson, but there's a lot of angles up in this diagram, right, to understand where those angles are. So QNP, right, is this angle right here. All right, QNP is right there, and MNQ is this angle right here. Now, because this is a rectangle, what we know is that all the angles inside of it are right angles. And that means that these two angles, you can say either add to 90 degrees, or the technical term, they are complementary. Right? So they're complementary, or they add up to 90 degrees. Letter B asks us to algebraically model the information given in the problem and determine the measure of both angle QNP and angle MNQ. All right, well, we know that their measures are going to add up to 90 degrees. We also know that the measure of QNP, right, which is this one, is 2 degrees more than 3 times the measure of MNQ. See if you can put all that together and figure out the measure of both of those angles. All right, well, again, notice that the measure of QNP, this angle, is based on the measure of MNQ, this angle. So just like before, what I'm going to do is I'm going to let this angle be x. And this angle is 2 degrees more than 3 times its measure. So that's going to be 3x plus 2, right? 2 degrees more than 3 times its measure. Now, if you put down 2 plus 3x, that's not wrong, but that's really 3x more than 2. 3x plus 2 is 2 more than 3x. A little technical, but whatever. Now, once I have these two down, and I know the two angles must add up to 90, then it's pretty easy, right? Because now all I have to do is say that x plus 3x plus 2 is equal to 90. All right, and this is pretty easy to solve, right? I can combine like terms. That's 4x plus 2 is equal to 90. I can subtract 2 from both sides, right? That's going to leave me with 4x is equal to 88. I can divide both sides by 4, hopefully. Divide both sides by 4, and x will be equal to 22. Right? And that's great, because that tells me one of the two angles. The measure of angle MNQ, which was equal to x, well, that's 22 degrees. Now, the other one's a little bit more challenging. The measure of angle QNP is 3x plus 2. It's I have to do a little more calculation there. 3 times 22 is 66, plus another 2 gives me 68 degrees. And again, another nice check, right? We talked about this in the first problem where we had supplements. Here we have complements. Another nice check is the fact that 68 plus 22 gives me that 90-degree angle, which I knew that I had. One last little part of this problem, right? And let me actually just write these two measures in. We know this is 22 degrees. We know this is 68 degrees. One last little part asks us for what the measure of angle NQP is. So again, really important to be able to visualize where that is on the picture, right? And then try to figure out how to find its measure. So pause the video now and see if you can figure out how to find the measure of angle NQP. All right, one of the cool things about finding the measure of angle NQP, which is this one right down in here, is that there are two very distinct ways of finding it, and yet they give you exactly the same answer. One way of finding it is taking advantage of the fact that the angle that we're looking for, this thing, is an alternate interior angle to that one, right? Because MN is parallel to QP, all rectangles are parallelograms, then this angle and this angle are alternate interior angles, so therefore the measure of angle NQP must be equal to the measure of angle MNQ and must be 22 degrees. That's the fast way of doing it, all right? But the cool thing is you can also do the following. You could say, well, forget about alternate interior angles. I know that this angle's 68 degrees. I know that this angle is 90 degrees, so we could also do our trick where we take our 68, add to it our 90, giving us 158 degrees, and then we could take our 180 degrees minus 158 degrees and find 22 degrees as well. Just using the fact that the three angles of any triangle, this angle, and this angle, must add up to 180. Isn't that amazing? I mean, these are just two totally different approaches. This one just takes advantage of parallel lines, and this approach, the second one, a little bit longer, takes advantage of the fact that the three angles of a triangle must add up to 180. All right, so let's keep doing some geometric modeling. Take a look at our next problem. All right, isosceles triangles. Exercise number 4. In triangle EFG shown below, side EF is congruent to side EG. The measure of angle F is 24 degrees more than the measure of angle E. Letter A, what special angle relationship exists in this triangle? And letter B, algebraically model the information given and find the measure of each of the three angles. All right, I think that you have enough now to be able to do this, especially given the fact that the last lesson that we did was on isosceles triangles. So you should be pretty comfortable with a picture that looks like this. So pause the video now, see if you can first identify the special angle relationship that exists in this triangle, so the special one, because there's obviously just the relationship that all three angles have to add up to 180. That's not a special relationship, right? But then once you know the special relationship, see if you can use it to model what's going on in this problem and to find the measure of all three angles. Pause the video now and take a few minutes to do this. All right, well, the special relationship that exists is the fact that the angles that are opposite of those equal sides are also equal. So in other words, the measure of angle F is equal to the measure of angle G. Come on, M, not gonna go. Oh, well, there we go. The measure of angle F is equal to the measure of angle G. So, right, how do we use that? Well, what we know is that the measure of angle F is 24 degrees more than the measure of angle E. Again, right, angle F, its measurement is based on angle E. So I'm gonna let angle E be that X, right? I'm gonna let that be that variable, right? Now what that tells me is that the measure of angle F must be X plus 24. Now, if you write those two things down, you might get a little stymied. It might be like, well, what do I do now? I mean, how do I solve for x? I don't have letter g in any way. Except the measure of angle f is equal to the measure of angle g. So if f is x plus 24, guess what? So is g, right? So g must also be x plus 24. And anytime we've got the three angles of a triangle all kind of filled in like that with the variable x or whatever variable you're working with, now we go right to our old kind of habit of saying, all right, if I take x and I add it to x plus 24 and I add it to x plus 24, I'm going to get 180 degrees. All right, we'll go ahead and we'll solve that in just a minute, but this is truly the equation that sort of models all the geometry that's going on in this problem. One piece of the geometry is that I've got those two base angles that are equal, so they've got to have the same sort of like equivalent expression in terms of x, right? Then I've got the fact that the three angles when added together equal 180. So let's do it. Let's collect some like terms. I've got x plus x plus x, so that's going to be 3x's. Then I've got 24 and 24, that's going to be 48. All of them equal to 180, right? I'm going to subtract a 48 from both sides. Calculators are helpful here, but not mandatory. That's going to be 3x is equal to 132, right? Divide both sides by 3. Cancel. 132 divided by 3 is going to be 43. Nope. Let's try that again. Let's try 44. Yep, that's right. And of course, that's now the measure of angle E, as it often is, right? The value of x or whatever variable we've chosen to use is oftentimes the value of one of our angles. There we go. So the measure of angle E is 44 degrees. The measure of angle F and G are just 24 degrees more. So the measure of angle F is equal to the measure of angle G, and that's just 44 plus 24 for a grand total of 68 degrees. All right. Another great test of this, right, is to take 44, 68, 68, add them all together, and see if they're equal to 180. If they are, it's probably a good sign that you've done everything correct. All right, let's keep going and do one last problem. All right, here we go, exercise number 5. In the diagram of triangle PQR, side QR has been extended through R to point S. It is known that the measure of angle P is 3x minus 20, the measure of angle Q is 5 times the quantity x minus 12, and the measure of angle PRS is 6x minus 24. Algebraically determine the value of x. All right, this might be the most challenging one we do, but I'd still like you to pause the video now and see if you can think of what the relationship is between these three angles, right? Or maybe it's just a relationship between two of the three angles. All right, one way or another, we have to come up with some geometrical relationship that allows us to solve for the value of x. Pause the video now and see what you can do. All right, well, a few lessons ago, we talked about the exterior angles of a triangle, the exterior angles of a triangle. And one of the facts we learned was if you add up all the exterior angles of a triangle, they equal 360 degrees. That's not very helpful here. But the other really important fact about exterior angles is that any exterior angle is then equal to the sum of the two remote interior angles, right? So this exterior angle is remote to these two interior angles, and it means that when I add this one to this one, it's gotta be equal to this one, all right? Now, that's an important fact about exterior angles, right? But it's also one that you could easily forget, right? But let's do it now, right? What I know is that the measure of angle P plus the measure of angle Q is equal to the measure of angle PRS. Okay, and now I can just set up a rather complicated looking equation based on that, 3x minus 20 plus 5 times x minus 12 is equal to 6x minus 24. And this is unquestionably sort of the most complicated equation that we're solving today, right? And yet we've got a lot of practice on these types of equations back in Unit 1, right? When we were working with equations that had variables on both sides and ones where we maybe had to do a little bit, like some distribution right here. So that's my next step. My next step in solving this is to take that 5 and distribute it through the parentheses. That's going to give me a plus 5x, 12 times 5 is 60, so minus 60 equals 6x minus 24. Now I'm going to combine some like terms over here. 3x and 5x is 8x. Negative 20 and negative 60 is negative 80. All right, and now we've got that classic variable on both sides of the equation. I think I'll move my x's first, so I'm going to subtract a 6x from both sides. That's going to leave me with 2x minus 80 is equal to negative 24. I'm going to add an 80 to both sides to isolate my variable. That's going to give me 2x is equal to 56. Now you might want your calculator on, or you can just think about negative 24 canceling positive 24 and giving us 56. And now I'm going to divide both sides by 2. 56 divided by 2 gives me 28. And I think, yes, we just wanted the value of x. You should watch out for that as well. Sometimes you're looking simply for the value of x. Many times you're looking for things based on the value of x. So once you have the x, you have to go back and do some substitution. In this problem, all I wanted was x. So x is 28. Now again, this is a tough problem for a couple reasons. One, it uses one of the lesser known facts that we went over in this unit, i.e. that any exterior angle is the sum of the two interior angles that doesn't touch it, that isn't adjacent to it. The other part that makes this more challenging is that we end up with an equation that is simply longer to solve. Therefore, there's more places where we could make a mistake. All right, let's wrap this up. When geometry was invented, and this was literally like 3,000 years ago, right? Or maybe 2,500 years ago, but you know, what's 500 years here and there? They didn't even have algebra, all right? But once we did have algebra, it allowed us to expand and model many problems in geometry that we couldn't have without it, all right? And that's what we spent today doing. We spent today looking at diagrams, understanding the geometric relationship that was going on in the problem, and then using that along with our algebraic skills to solve the problem in geometry. All right, so were we doing geometry today? Were we doing algebra? I think we were doing a little bit of both. All right, and we're going to do a lot more algebra as this course goes on, and a little more geometry. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.